Hey guys, welcome to the first video on how to solve a KenKen puzzle. For this first video, we're going to use a 4x4 KenKen puzzle. This is a very easy puzzle. It's probably a good example for our first video in learning the basics in solving a KenKen puzzle. The first thing we need to do is understand the rules that are um, that govern this puzzle. First thing about this, the first rule is that for each column and row, you cannot have any repeat numbers. So numbers 1 through 4 needs to fit here, 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 and here. Essentially, any row and column needs to have the numbers 1 to 4 but not repeat. Rule number 2 is to combine any number of cells, one or more, to a number on the left hand corner here using this operator, whether it's a addition, a subtraction, a multiplication, or a division. In this example, these two cells needs to subtract to amount to a 1. If we could just think about this for a little bit, numbers 1 through 4 using a subtraction amounting to a 1. A couple of numbers comes to mind, 4 and 3 and 3 and 2. Now this here is what is referred to as a cage. You have a cage here that encompasses two cells using this operator to amount to the number 1. Let's take a look at another cage. This here is another cage. You could tell because of the heavily outlined here, encompassing these two cells. The operator here is a division, and it needs to result to a 2. There are two numbers from 1 to 4 that could result in a division of the number 2. 4 and 2 and 2 and 1. And essentially that's the basic. The amount of strategies you could use here are quite a number here. We're not going to go too much into the specific strategy names and whatnot at this point. We're simply going to just solve this puzzle and apply some basic strategies to solve this puzzle. If you look at this puzzle, the easiest cell to fill out would be these single cell cages. And the reason for that is because the resulting number for this cage slash cell, single cell here, needs to be a 2. There are no operators. Therefore, for this particular cell, the number that goes in here is 2. Same goes for this cell here. That's a 3 because it needs to combine to a 3. There are no operators here, therefore it has to be a 3. This is what is referred to as a freebie. So let's fill in all the freebies to start the puzzle. This is my way to start every puzzle. Everyone has a different way to go about it, but I always find that filling in the freebies first is a perfect foundation to move forward with the remaining cells. And to illustrate this with this example, we're going to look at this column here. We know this is a 1, right? We solved that just a moment ago. The numbers 3 and 4 has to be here because the only two numbers 1 through 4 that could add up to a 7 is 3 and 4. We don't know what order the 3 and 4 is going to fit. At this point, it's not important for us. We just want to make a mental note that 3 and 4 fits in this cage. we have a 1, we have a 3 and a 4, order of which is not important at this point, and we could conclude at that point that this has to be a 2 because you have 1, 2, 3, and 4, or 3 and 4, order not determined at this point. Moving to this cage, we have a summation amounting to a 3. We know one of the numbers is 2. The only number that would make sense here is a 1 because a 1 plus a 2 is a 3. And for this row here, we know this is a 4 because that's the only number that can fit in here. Looking at the next cage, multiplication amounting to a 16. We know that a 4 times a 4 is a 16, and the only other logical number would be a 1. No other number will work in this cage between 1 to 4. Now we know a 4 can't go over here because that would be a repeat for this column. So the 4 goes here and the 1 goes here. Let's just take a moment and analyze what we have here. We have 4 times 1 amounting to 16, so this checks out. We have 2 plus 1 amounting to a 3. This checks out. And we are now on to what I've referred to as a freebie, because the only number missing here is a 3. That makes this a 4, because we knew when we begun this puzzle that a 3 and 4 is here. We didn't know what order it was going to be, but knowing that this is a 3, this has to be a 4. And it also fulfills the requirement for this column to not have any repeats. That works out pretty well. We know a 4 has to be in this column. We know it can't be here because that would be a repeat in this row. Therefore, the 4 goes here. The cage we're looking at here needs to sum up to a 7. A 4 is a number we know we have. Therefore, a number 3 fits in here. We know a number 2 is here because you can't have 1, 2, and 3. That would be a repeat. That forces the 2 here. And that would give us a 1 here because that's the only missing number. Also, even though a 4 will work for this operation, it can't be a 4 because there's already a 4 in this column and there's a 4 in this row. So if we could just backtrack a bit, it wouldn't have mattered whether we solved this or not, because we solved this, and therefore we were able to come up with this number. Had we not come up with this before, we probably could have figured this out too, because we knew a 4 was going here. And with the exception of figuring out here, we knew, let's say we had a different way of finding out 3 and 4 living here, we would know the 1 has to be here. So the order of how I did this is not important. We came to the conclusion in a number of different ways. And here, through the process of elimination, we could complete this puzzle easily. We know a 2 must be here and a 3 must be here. It also satisfies the requirement of a 3 minus a 2 amounting to a 1. And that's our first puzzle. It's a really easy puzzle. Normally you could solve this in about a minute or 2 when you get used to it. Hopefully we could move on to a harder puzzle the next time we do this. And I hope you enjoy this video.